Again, hi everyone. Welcome to the LPS session. In this lecture, we are going to continue to look at Python. Just as a recap, we covered many things with Python. As you may recall, we started with the basic data structures. We went through some of the control structures. We started talking about some of the advanced data structures like tuples, lists, and then we went into the dictionary essentially, which is the associative arrays. Then in the last lecture, we covered new items like lambda functions, which is like a function generator, and then we went over some of the default functions that are provided with as a part of Python. So I hope all those things are clear. Today we will start with actually another section basically, and this is we're going to talk about the exception handling. So this is like when you have some exceptions generated inside the code. How does the program handle it? How do we handle it? Things like that. That's what we talk about. So the exception in general is a recognized type of error, and handling is what you do when that error happens. So the general syntax of exception handling is this call called try. Very similar to a function, but it's not a function, it's a predefined function. And then basically what we say is we say try the code you want to run, except what are the exceptions. So exception 1, and then if it is exception 1, so for that what is the block of the code, then we do exception 2, and then what do we do, and then all the way up to the last exception, which is exception n, and then we specify that as variable 1. So essentially this is the general syntax of the exception handling. So now what this means is, this code means is that if an error occurs, and if it is of exception type 1, which is here, then we set the variable 1, it becomes an alias to the exception object. So that's specified here, and then this block of code starts executing. Exception 1 block executes. Otherwise, Python tries the exception types 2 all the way up to n until the exception is caught, or else the program stops with an unhandled exception. The as variable is an optional one, and this will not work with older Python. So this is like 3 and above. So let's look at a quick example. So value error dot actually this should be py. So here we say try I equal to int of snakes, and then print the integer is something except value errors. Here we omitted that as variable, print oops invalid value. Now there can be other exceptions. One of the exception is this end of file exception. end of file error is raised at the end of the file. The index error happens if we use an invalid index for a string or a collection. Example, if we try to get argv1, if there is only one command line argument, which is basically like argv0, then it generates an index error. And then there's also another one is called type error, which is if you're trying to compare two different types, incomparable types, like string versus float or something like that. So again, that is the type error. So essentially, like I mean, so there's a in general, like I mean, a value error, end of file error, and then index error, and then the type error. So these are the general exceptions. So that you want to keep in mind. Now let's look at some of the Python modules. So in this section, we are going to talk about the basics of modules, import and from, import statements, and then how do we change data inside the module. We'll also talk about reloading the modules. Then we will talk about the module packages, then name and main, then finally how do we import as a statement. So now let's look at the Python modules. So couple of more things regarding the before we go into the modules, I want to also highlight some of the other things about the exceptions. So we talked about some of the things basically. So the other ones essentially you can also have standard error, which is basically the which can be like any all the built-in exceptions except the stop iteration, generator exit, keyboard interrupt, things like that, or system exit. They're all the standard error. And then we can also get an arithmetic error, which is essentially like I mean various types of arithmetic operations which can be generated from the arithmetic operations, like overflow error, zero division error, or floating point error. And then there is also buffer error, which is essentially like I mean when the buffer related operations cannot be performed, you can get a buffer error. And then there is also lookup error, which is the index error is one of them essentially, or even the key error is also the other one, which is all like classified under lookup error. And then the things like IO error, even this end of file error, these are all under the environment error, which is concerning with outside Python system. So IO error, OS error can also be with an environmental error. And there are some assertion errors, basically when an assert statement fails, attribute errors, then an attribute reference or attribute assignment fails. We also have talked about the floating point error, basically when the floating point operation fails, and then there's the generator exit in general. So all these things are comes under the exception class of the in Python. So they are basically like there's a basically it's a base class that is for all the exceptions. So now let's look at the modules, Python modules. So what is a module? First of all, each file in Python is considered a module. So this module actually, like, I mean, we saw it in Perl as well as actually, like, in Tcl we didn't see that much, but in Perl we saw um, the modules essentially. Um, so everything within the file is encapsulated within a namespace, which is basically the name of the file. Okay. So to access code in another module, another file, we need to import that file and then access the functions or the data of that module. We can do it by prefixing with the name of the module followed by a period. But to import a module, we just use the function called import and with the argument as sys. So one thing you note is basically, like, there is no file suffix for this particular module. We can also import user defined modules or some standard modules like sys and random. So in this case, like, sys is like a standard module, but you can also like to user defined modules. Any Python program needs one top level file which imports any other needed modules. So the way it is organized as a top level file which imports other files. So in the Python standard library there are over 200 modules, and essentially, like, I mean, you can go to python.org and then you can consult the Python library reference manual, and for all these different modules in the standard library. So now what does the import do essentially? So the import statement does three things. It finds the file for the given module, it compiles into a bytecode and runs the module code to build any objects, basically whether it's a top level code and then variable initialization. The module name is only a simple name. Python also uses a module search path to find it. It will search the directory of the top level module or the top level file. Directories inside the environmental variable called the Python path, and then the standard directories, and then finally the directories listed in any of the path files that is in your directory. And then here it is basically like one directory per line in a plain text file. Essentially, that's how you want to specify the .pth file. The path can be listed by printing sys.path. So if you say print sys.path, it will list the path. So here is an example for printing the command line arguments. Print argv.perl. So here we import the sys, and then the command options are sys.argv, and then basically, like, for initialize the variable I, and then for command in command options essentially, which is all these ones, we just print the argument I and then the command, and then we just increment. So it basically prints once we specify this essentially like arg0 is print arg3.perl and then test1 and test2. Now there is another module called random. So random also can be imported. So we import random, and then we say basically random dot rand integer between 1 and 100. So this is essentially it's a random number generator between 1 and 0. I mean sorry 1 and 100, and then we can print that, and then we can also like specify like a random dot choice, and then we can pass a list, and then we can make it to print the dinner, and then it randomly picks one amongst those three. So here we notice basically like this random function, and we also say like rand int to make sure that this output of this one is an integer from these values. And here we just specify simply like choice, and then basically like the remaining ones are strings, and then essentially like that gets printed out. So now let's look at the difference between import and from import basically. So from this whole thing, right? So when we say import brings in a whole new module essentially, the whole module essentially, and we need to qualify the names by module name. So that is using this sysrg. But import from copies the names from the module into the current module. So no need to qualify them basically. So we don't need to actually qualify with these additional names on it. So it is actually brought into the current module itself. So and notice that actually these are full copies basically, not links. So essentially you can change, and basically like it is not going to override any changes to the original ones. So you have your own copy, and then your copy will be different from the one inside the module itself. So here an example, from module X we import junk, and then we directly call junk. We don't call as module X dot junk anymore. So now when we specify this command, the junk actually now gets transferred, and then basically it is copied and kept it as part of your module and not part of the module X anymore. And then you can say basically like from module X import star, that gets all the top level names from module X. Now the changing the data inside modules essentially. So you want to reassign a new value to fetch name from module from a module which does not change the module, but changing the mutable variable from the module. So essentially like from module X import XY. When we say X is equal to 30, it doesn't change X in the module X. So this is something that we talked about earlier. But if you put as Y0 equal to 1, that actually changes Y0 in module X, because now it has no bearing of this 0 inside this particular your own module, and it needs to go back to um, um, the module x to find out what is y0 and then change that. So this is similar to like exactly like the functions. So to actually change a global name in another file, we could use import without the from and qualify the variable. But again, this breaks the data encapsulation, because now we say like module x dot x is 30, and then any kind of object encapsulation that the module provides is completely wrong. Now how do we reload modules? The module's top level code is only run the first time when the module gets imported. Subsequent imports do nothing basically. So the reload function forces a reload and rerun of that module. So you can use if there is a module changes while the Python program is running. So essentially, like if you change the variable and basically you have to re-import the module, then at the point you can use the reload. And reload is passed an existing module object, for example reload module x, and then the module x must have been previously imported. So you cannot do an import with a reload command. And then the reload changes module object in place, basically like whatever that was imported, it changes that essentially, and it does not affect prior from import statement. So once they are copied into your own particular module, those will not change even with the reload. Only the import, the regular import, will be the only one that will change, and they still point to the old objects. If you do another from import, of course that will change basically after the reload. So now let's talk about the module packages. So when using the import, we can give the directory path instead of a simple name. So the directory of Python code is known as the package. So for example here import directory 1 dot directory 2 and then module. So or we can also say like from directory 1 dot directory 2 module import x. So essentially what that means is basically look for the file directory 1 slash directory 2 and then module.py. And one thing is directory 1 must be within one of the directories in the Python path. So the Python path is now important, similar to what we saw in regular import modules. And the other thing is also like directory 1 and directory 2, they should be simple names, not the platform specific syntax. That is C:/ or backslash or whatever. Now underscore underscore init underscore underscore dot py. These are some of the package files. So when we use the Python packages, basically the directory path syntax for the imports, each directory in the path needs to have this underscore underscore init underscore underscore dot py file. This files could be just blank, basically. I mean, if it is it's nothing basically, or if it is not blank, the file contains the Python code. The first time Python imports through the directory, it will run the code in the underscore underscore init underscore underscore dot py file. So in the directory 1 dot directory 2 module example, the namespace directory 1 dot directory 2 now exists, which contains all the names assigned by the directory 2's underscore underscore init underscore underscore py file. The file can contain an underscore underscore all underscore underscore list, which specifies what is exported by default when the directory is imported with the from statement. So now this actually uses another concept of data encapsulation. So by default, names beginning with an underscore will not be copied in an import statement. They can still be changed if accessed directly, so that's no issues. Alternatively, one can list the names to be copied on import by assigning them to a list called underscore underscore all underscore underscore. So for example, here we specify like underscore underscore all underscore underscore, and this list x1, y1 and z1, and to mean that basically import only these this list is read only like we need to import these two, basically x1, y1 and z1, and this list is a read only, and when it is using the from star syntax, so that is the one, the from import from syntax that we saw. So this list is read only when we use this from star, so that when you use the import from and then star, it only imports these three, even though it may have many other. So now the same thing, basically like underscore name underscore and underscore main underscore. So when a file is run as a top level program, its underscore name underscore is set to underscore main underscore when it starts. So this is how so this is the concept which is very similar in like C language. In C, always the execution starts with this function called main, and it only executes that, and then any other functions are underneath that. Similarly in Python, basically the underscore name underscore is set to main when it starts, so that it runs that as the starting point. But if a file is imported, the underscore name underscore is set to the name of the module as the importer sees it, and can use this to package a module as a library, but allow it to run as a standalone also by checking if the name, the underscore name underscore is the same as underscore main underscore, and do whatever basically that will run in the standalone mode. So now the next one is this import as. We can rename a module by using import long module name as short module name, where the short name is just an alias for the original module name. We saw this thing in the very first slide when we did the example for importing, where we said the import, or actually like in the exception handling essentially. So try, and then we say basically like an exception as variable 1. So there that long name is assigned to the short name essentially as with the using the as. So the same thing is applicable even to the import statement. So import long module name as short name, and then the short name is the alias for the original name. So when we start using this syntax, basically like we use the short name thereafter, and we don't have to specify the long name. We can also use the same as syntax for the from, basically. So from module import long name as the short name. That's another thing that we can do. Yeah, basically here X or whatever, like which module. And we saw this thing basically on the reload. The reload may not affect the from imports essentially. So when we do from copies, so basically the from actually copies names the and does not retain the link back to the original module. So that's why if you do a reload, you won't get the new one for those modules that are imported as from. So when the reload is run, it changes the module, but not any copies that were made on the original from the module import from module import X statement. If this becomes a problem, then we need to import the entire module and then just use the name qualification, just like module.xxx just that kind of a name instead of this from statement. So now we come to the files section. Here we are going to just talk about some basic file operations. So quick commands, how do we open a file? The command is open and then we just specify the file name and the mode, and whereas the file name is just a Python string, the mode is also a string basically, and then it is string R for reading, W for writing, and A for appending. So the basic operation is basically out file open out.dat with write option, in file open input.dat, and then with the read option. Simple stuff. We saw these kind of things both in Tickle and Perl already. And then some of the basic operations. So once we open the file, we specify input.read, and then that reads the whole file into a string. This also we saw like in the previous examples. And then we can also read by number of bytes essentially, like so that is again read n. The n specifies the number of bytes, so it reads so many bytes from the file and keeps it. And read line is to read the next line, and we can also specify read lines to read the files into a list of strings. And then similarly for writing some output, basically we use the output.write, and then if we specify the string A, and then the string A is written into the file. And then we can say like write lines A to write a list of strings into the A, and then we use the close function output.close to close a file. Now how do we redirect the standard out? So the print statement normally go to the standard out. The standard output is basically the screen, and then we can actually redirect the std out into a file. So here we basically import the sys module, and then we specify sys.standardout is this particular file called output.txt, and we open it with the write option. Now when we specify the print message, it will not show up in your screen, but it directly goes into this output.txt. Alternatively, we can also print some things basically to a file using the print double arrow, and then we specify the file and then the message. And then for this, the only condition is that the log file needs to be open. So here are some examples of file parsing. This file parsing, like I mean, we saw this in Perl a lot of times. So here, how do we do it in Python? We specify the in file, basically like what is the in file with what kind of option, and then we start reading the lines basically. So the lines contain a list of the strings of all the lines in this file, and then we can after we read it, we can just close it. Now to print the line, essentially like we use the for statement and then basically print line, and then that prints one line at a time. And then there is also like a shortcut syntax to avoid read line calls. Basically that is line by line. So we open the file and then basically like we so here once we specify the line by line, essentially like I mean then we can just read the lines one by one. So here we can directly read this in file and then print those lines. So just to recap, today we saw three major things basically. The first one is on the exception handling. How do we handle exceptions? And we covered many different types of exceptions. And in general, the syntax is like this try and catch essentially. The try syntax is for the exception handling. Then we also covered the various module commands. So we went through the basics of modules, how to import modules, how to use the from import commands. Then we also talked about various types of modules like the sys module and the random module. And then we went through like how do we reload modules, what are the effects basically, and then how do we define packages, and then what are the some rules that govern the package specification, and then how do we actually change what gets imported and what gets run. And then we went through the file operations basically, how do we open the file, how do we close the file, how do we open it as read only, how do we open it as write, and then how do we actually do operations, essentially how do we read from a file and how do we write out into a file, and then also like how do we redirect some of the standard outs files, and then we also went through the file parsing essentially. So that's pretty much it for today. We will pick up the stuff from this point in the next class. Thank you very much.